Thank you, sir. So once again, on behalf of my team and English Technologies, I welcome everybody from UAE and India for this webinar. It's a great opportunity to uh, present the capabilities of NX CAD here in front of you. So let's move on to the topic. We're introducing Siemens NX design. Siemens NX is a flexible and completely integrated solution that enables faster and powerful product deliveries. So more than just a CAD solution, NX caters to various aspects of a product, which starts from the design stage to validation and manufacturing. So it's a complete integration of mechanical, electrical, process, and automation, which can be tailored as suitable to the user. NX is the next generation design platform that removes barrier to innovation, seamlessly combining multiple disciplines such as modeling, generative design, and so forth. NX enables more iterations by both experts and non-experts and utilizes the latest manufacturing methods to ensure that you recognize the value of digitalization. So these days, definitely products comprise of multiple disciplines, and in such scenarios, NX allows all of your engineers and designers to collaborate and share information on a common platform. So why NX as a technology platform? When you look at the deployment ability of NX, you do not have to wait to take the advantage of the latest advancements, of the latest release that NX comes up with. So it's being deployed at the largest engineering enterprises in the world right after the new versions are released. And data preservation is a hallmark of NX. NX will never force you to leave your data behind when you move on to upcoming or latest releases. And NX definitely responds to the open technology paradigm, where working with multiple compatible solutions from Siemens or even from third-party vendors is a scenario. Coming to market trends these days, customer expectations are always on the rise, and demand for reduced time to market, collaboration between different departments such as mechanical or electrical and automation, techniques for non-linear and complex designs, and also change management are also on the rise. So all this pushes for a transformation towards new concepts. We may name digital twins, increased collaboration, and definitely the design reuse as some of the key things that customers expect in the market today. So when you talk about digital twins, it could be a twin of a single component, multiple assembly, or it could also be a digital twin of a complete manufacturing unit setup. It definitely helps us in accelerated time to market and definitely helps in improving the quality of the design.
063317.
So users expect better collaboration features, not only from within the organization, but also with stakeholders around the globe. So along with all this data reuse, digital threads, and closed loop systems have become the general norm in recent years. Focusing on the design strength of NX, NX comes packed with various features such as synchronous technology. So with synchronous technology, you get the ability to edit imported data or pre-process your models for CAE purposes. NX is a leader in generative design, convergent modeling, which is trademark of Siemens, and also designing for additive manufacturing. Now, NX having been trialed and tested in the market for a very long number of years is a very stable design solution because of the various enhancements that has been made based on the customer feedbacks and use cases. And when you speak about the design versatility that NX gives you, you get the benefits that most CAD or your CAM solutions in the market can deliver. Now, NX is the world's most robust modeler. But how? So we have something called a selection intent, which helps us to select the different geometries, the different entities very effectively. And it supplies you with a very intuitive and interactive user interface. The model resolution time is significantly slower for in case of design morphing solutions. And the most important thing to note is that NX runs on the Parasolid kernel, which has been tried and tested and still being used by a huge number of designers doing heavy duty model creation around the world. Let's talk about selection intent. As I mentioned, selection intent allows for optimized and associative collection of entities following a recipe. So when you open a specific command or when you are undergoing a specific process in NX, you get the ability to choose different curves, faces, or edges that is relevant to those commands in a very easy fashion. So the selection intent rules are based on the feature creation, and it basically makes the interface more intuitive. NX is highly flexible with the efficient and smooth integration of wireframe, surface, solid, and even facet modeling tools, all coming under one single environment. So with this integration arises abilities such as convergent modeling, subdivision modeling, and synchronous technology. So when we talk about surface or solid modeling integration, modules such as Shape Studio or NX Realize Shape enables users to create rapid surface geometries, which can also be combined with the solid models in one environment and can be analyzed with built-in analysis tools. So the surface modeling even supports G3 continuity connections without the requirement for any third-party solution for higher order surfacing activities. And the tools are also oriented in such a way that whatever application you are looking for is available for your use. Now, convergent modeling is a concept in NX that allows the user of both VREF data and FACET data to use it in a single environment in conjunction with each other. So with NX, you can forget the need for two separate tools for dealing with VREF and FACET data separately. In the end, your model could just be a normal VREF model, or it could be an enhanced and well-put combination of VREF and FACET model. Obviously, you get the choice. It enables working with scan data directly, and hence the reverse engineering requirements are reduced to a great extent. The scan files can be directly imported to NX, and the modeling process can be started on the go. And finally, whatever models we create can definitely be used in the downstream processes, such as additive manufacturing or our other conventional manufacturing processes. So synchronous modeling. Now, this is another proprietary Siemens technology that allows you to edit your data no matter where it comes from or the current state of your model. You have the ability to make changes on the models that have no history at all, or on history-based models that have not taken into account any changes that are required. So synchronous technology enables you to make faster changes and accelerate development cycles even with legacy geometry. It's also a big game changer for engineering analysts and manufacturing users who make dramatic process improvements by working directly on design geometry. The result is obviously shorter product development lead times and improved product quality. Here is a video of synchronous technology being depicted on a fan housing. So initially, we'll be using a synchronous technology command called as a move face, wherein we can select a particular face, and then the appropriate direction can be given in terms of vector, and also the movement can be given in terms of the value, or you can measure it directly from the model. So you can see as the face is being pulled, how the bracket is being lengthened. Then we can use rubber band selection to select a set of faces rather than a single face for movement. So in this case, you can select a closed surface group and you can move that whole feature to a new location. Another interesting feature is the X form or I form, which can be used to manipulate surfaces in a free form fashion. So when you consider this analytical boss, you can select the faces, then you can parameterize it based on your requirements, and then you can work on the nodes and the control points to generate a free form surface. So as you can see, when the change is being made on one side of the model, the symmetric side of the analytical boss is also being changed accordingly. Now, this is something called as design intent, where software automatically understands based on the way it was modeled earlier. Now, rather than just working with faces, we also have the opportunity when we are using synchronous technology to use dimensioning tools such as our linear dimensions or radial dimensions or even angular dimensions to change the dimension or the shape of the overall body. So in this case, we'll use the radial dimension command, and we have different constraints or different selection options where we can find, say, coaxial faces that have to be moved together, or coplanar faces that has to be moved together. And finally, we get dynamic preview once we enter the value, and then we can choose to decide any modifications based on that. Again, we can see based on the type of geometry we select, we have the opportunity to select more faces that has to be moved along with it, so that the final design is relevant to what we are looking for. So far we were dealing with single or say a few group of faces, right? But what if we were dealing with multiple faces? So in this case, what we are doing is we are going to select the entire group of faces. So this can have more than like 100+ faces in the selection group. So you can see there's almost 1964 faces being selected. So once the selection is done, we have the option to again move it, or you can change the orientation. And during the imparting of the motion, rather than entering a particular value, you can use options such as point-to-point movement, where you can choose a reference point and then move it with respect to a target point. So we can see the rework on a large scale, such as what's shown here, that could take several days in understanding and editing the parametric modeling features, is being done in very few minutes using synchronous technology capabilities. Other than this, we have the option to delete faces or even delete holes, resize blends, resize chamfers. So all these possibilities are there in synchronous technology modeling. Now here is another small video clip depicting the modeling of a drill bit for the oil and gas industry in NX. So in NX, again, there is a dedicated sketch environment with extensive sketching commands. So drawing, for instance, continuous profiles is made easy using the profile command, which is a combination of the line and the arc. So we can choose whether we want the line or whether we want the arc. Also, we get a collection of persistent and non-persistent geometric constraints that can be used while sketching. The commands in NX are always grouped pertaining to a specific workflow that imparts certain logic. So be it sketching or even in other applications. Even the Boolean operations are built into the extrude or revolve commands as well. Now to access or impart different curve features such as splines, helix, or even advanced features such as isoparametric curves, to name a few, there is a separate curve tab where we get to choose all these options. And again, like I mentioned, from time to time, we always have the ability to directly measure from the model and impart the value into the command. Then there are multiple options to add sketch planes at any point on the geometry. So apart from basic input parameters for the planes, there are curves and points that we can use to orient our planes in virtually any location on our geometry. So let's complete this helical vein by adding a profile. As you can see, it's a single chain that we are trying to make. Once that is done, we can use the extrude two-sided offset to basically add a surface and directly unite it with the existing body. Then features such as phase draft can be done with respect to a stationary phase, or they can choose the edges as well to get the optimum result. And then coming to features such as chamfers or edge blends, we have the option to basically limit the flow of the surfaces using variable parameters or limit faces or limit curves. And again, the selection is also made using various selection filters. So in the end, the thing to understand is the amount of control we get in even the simplest commands so that we get the optimum design that we wish for. And patterning is also made easy using the pattern command, where apart from the normal circular or table pattern by table or the rectangular patterns, we get pattern along edges or pattern along curves. And using synchronous technology, we can also pattern groups of faces. So earlier we saw movements. Here we are seeing how it can be patterned. It can be either patterned or you can completely cut or copy it and put it in a different location. So all this is being done regardless of how that particular feature was created. And finally, we can add an extruded cutout and also an extruded boss on the top plane. Then NX has an inbuilt holds database that pertains to different industrial as well as international standards. And we also have different abilities such as, aligning the holes with respect to lines or with respect to other vectors. So with the combination of both history-based and synchronous modeling, the design time and the effort required by the designer is significantly reduced. Now let's talk about assembly design. So when it comes to assembly design, NX is created and optimized in a way that allows for practical and effective design in the context of the assembly itself. As the number of components and the design complexity increases, NX has the right set of tools for the assembly modeling. So from modeling components from scratch, or if you want to edit an existing model in the context of an assembly, there's nothing better to do, nowhere else to do rather than in the NX environment. So features such as product interfaces lets us use the same reference point for multiple components. Then wave geometry linking enables to create associative copies of entities or even complete bodies from one part to the other. With the added benefits of inter-part relationship tools such as browsers and replacement assistant, it always makes the life of a designer very easy. And such approaches also encourages a multi-user design scenario. Here's a video of an aircraft landing gear which depicts modeling in the assembly context. So we have an assembly navigator on the resource bar, which you can see on the left-hand side. The components and sub-assemblies are structured in a very accessible manner. At this point, we can choose the different selection filters to get the right set of geometry selection for the command we want to execute. And since we're working in the context of the assembly, we definitely have the option of comparing the changes that we make with respect to other components. And navigating to assemblies that have multiple components is also very easy with different selection filters and even zooming options, panning options, etc. So let's see another example where the edit is being made to a part that consists of tube root as well. So here we are using the synchronous technology command itself yet again. And while using the synchronous technology command, when you select a body or multiple faces, you have the option to choose the reference point that you prefer. As shown here, you can change the reference point that you want. And you have multiple options to choose the movement. So here you can select the point-to-point movement or point-to-face movement so that your time is significantly reduced. You can see the tube routing also updates very efficiently and automatically. Now design reuse. With more design activities coming our way, design reuse always plays a vital role in making the design process as efficient and as consistent as possible. So commands such as copy paste allows users to reuse 2D or even 3D features. So these features could be sketches or even 2D geometry from drafts and even 3D part features. So the function of user-defined library or user-defined features helps designers create and manage their own customized set of 2D or 3D features. And when reusing these features yet again from the reuse library, we get the customization wizard that lets the user change the exposed variables to get the right design. A product template studio is a module in NX that allows to build design templates that can form the basis of a product platform for reuse. So modular design approaches are strongly favored by machinery companies, right? And product template studio is just the right fit for that. So the templates are best utilized for parts or assemblies that have high reuse and may be configured differently based on the customer's needs. Not only the data, but the CAE, the kinematics, the PMI, all those things can be configured and configured and inputted into the templates for use. And that too, without much of a coding knowledge, a user is able to customize and reuse this data downstream. That too for a wide spectrum of designs. Here's a video of how the product template studio is being utilized for a conveyor. We'll start by loading the conveyor assembly template from the reuse library. So the conveyor assembly has been created using the product template studio by a designer like you and me. We can see that the editable parameters are exposed in the PTS dialog and allows the user to quickly select and shape the conveyor. The design criteria exposed to the user here include, for instance, say the length, the width, the spacing between the rollers, and even the input parameters for the support structure. So the designer can very quickly change the values and propose several different ideas and sizes, and then decide the best one that suits the need. So all this is customizable through the product template studio. Now coming to NX drafting. NX drafting, yet again, like other modules in NX, comes completely integrated into the NX package. The capabilities such as associative dimensions and annotations always make sure that the model drafting is up to date with recent changes in the part. The tools are organized inside NX in a way as to enable an efficient workflow from sheet setup, view placements, and also the detailing part. The NX drafting also supports creation of custom library symbols, 2D to 3D workflows, and also custom drawing templates. It's also easy to work with drawings from other CAD applications inside the NX platform. So all these capabilities are obviously compliant to different industrial and international standards. So NX Sheet Metal. NX Sheet Metal provides a complete set of tools within the NX design environment that allows for simple and fast design creation of sheet metal parts depending on the material standards. So NX Sheet Metal is designed with familiar terminology and workflows, which makes the learning curve very smooth for new users. The commands in the design process is built keeping the manufacturing aspect in mind as well. So with the ability to produce, for instance, say, accurate flat patterns for downstream processes, the wastage and the rework is reduced significantly. So for industries like aerospace or even automotive industries where non-linear or complex models are required, there is always the conjunction with advanced sheet metal and advanced surfacing mechanics. Let's look at the aspect of design simulation in NX. So Siemens has the simulation technologies that can help you get the result you need quickly for a very wide range of physics domains. So the overall name given for the solutions that they provide is Sim Center, and it covers the most common simulation types performed by design engineers, such as structural, thermal, CFD, motion, and vibration analysis. But for those people who are looking for a bit more in-depth understanding of their product, product or the component, simulation capabilities like for advanced physics like durability, acoustics, electromagnetics, multiphysics, and other options are also available. Simulation is no longer just a performance validation tool, but it's becoming an organic part of the development process through concept and design as well. So simulation is helping designers create better and more robust designs earlier in the development process, at the same time speeding the overall time it takes to release a design. So the NX CAD embedded simulation helps you to gain better insight into your product's overall performance from an earlier stage itself. Now, when you talk about the interoperability of NX, definitely Solid Edge will come into the picture. So the value of NX and Solid Edge interoperability is that it allows for automatic integration. This in turn will reduce the design time and promotes a better and collaborative environment. Some of the many benefits include large-scale design integration, increased productivity, and collaborative engineering. So NX and Solid Edge will work in harmony, allowing you to optimize your time, your design, your budget, and your communication. Then we have Team Center integration for NX. So Team Center is a modern and adaptable product lifecycle management system that helps us to connect and bring together different people, different processes from and different data from variable and functional silos with a thread for digital with a digital thread for innovation. Since you get all the source of product information to support your design from a single source, your manufacturing process and your design process, everything becomes much more streamlined. Then the reduced development cycle time for the teams that are distributed around the world is also a good benefit. So higher levels of understanding and communication among different teams and different suppliers and customers throughout the supply chain, then less time spent by designers and the stakeholders in finding the right data, then faster product change and approval processes to enable shorter time to market, and the ability to integrate not only Siemens but even other third-party applications inside a Team Center will definitely help streamline your overall design journey. Not only design, definitely from the ideation to the realization of your product. Let's just quickly go over the summary and the benefits. So NX enables an increase in 3D data usage for designs and reviews. It's strongly built based on different industries and applications, and it requires and definitely you get higher concentration on industry-built workflows rather than a random structure. So the different assembly tools in NX enables multiple person approach towards assembly modeling and also seamless switching between the different components in the model. So powerful modeling tools such as synchronous technology and conversion modeling allows for faster design edits and definitely regardless of the model history or from where this model was developed. The design data can be stored and reused down the line using features such as user-defined library or product template studio, increasing your design efficiency and design consistency. And definitely we get the benefits of integrating NX and Team Center and also the interoperability of NX and Solid Edge to work in harmony with each other to optimize your design, your budget, and your communication. So this comes to the end of NX CAD. At this point, I would like to invite Sandeep sir to carry on with the camp session.